Let's start with ozone layer and ozone layer depletion. We know that ozone layer is present where? Ozone layer is present in stratosphere. Clear? And it is present in stratosphere from, the stretch is what? The stretch is from 15 to 50 kilometers. That's the stretch where O3 layer, ozone layer is present in stratosphere. And we can know that, we also know that ozone is not naturally present in stratosphere, but it's formed. And how it is formed? It is formed due to the action of sunlight on oxygen molecules. See what happens when sunlight falls on oxygen molecules. This oxygen molecule would be splitting to form oxygen atom. Clear? This oxygen molecule would be splitting to form oxygen atom. And the splitting of oxygen molecule into oxygen atom is called as what? It is referred to as photolysis. The splitting of oxygen molecule into oxygen atom would be called as photolysis, and this oxygen molecule would be combining with oxygen atom to form O3. So, this oxygen ozone cycle is referred to as what? It is called as Chapman cycle. So, it's called as what? It's referred to as Chapman cycle. So, that's how ozone formation takes place in stratosphere. But the first question is that oxygen is also present in troposphere, and sunlight is also present in troposphere. So, why then ozone is not formed in troposphere and only formed in stratosphere? When we talk about making of ozone, manufacturing of ozone in the lab, ozone is made. How? By giving an electric spark, through an induction coil, to oxygen. So, when the electric spark is given, then ozone would be manufactured in the lab, then ozone would be developed in the lab. Clear? But when we talk about ozone is also purifying agent for air. Ozone is also sterilizing agent for water. You can see the new ROs that you purchase. In those ROs, we can see that ozone is used as a sterilizing agent for water. Not only as a sterilizing agent for water, but also we can see that ozone is used as a purifying agent for air also. So, these are benefits of ozone. But if the question is asked like this, that why ozone layer is confined to stratosphere and not present in troposphere, there are many reasons for that. Now, one reason is what? That why it is confined to stratosphere. First reason is that when we move upward in stratosphere, temperature also enhances. But if we move upward in troposphere, temperature reduces. So, first is temperature enhances if we move upward in stratosphere, but in case of troposphere, we can see temperature reduces when we move upward. Now, in that case, what will happen? In troposphere, there would be mixing of air. In troposphere, there would be mixing of air. In troposphere, there would be not only mixing of air, but convectional currents. So, if suppose ozone layer is formed in the troposphere, it won't be stable. It would be moving upward and downward because of mixing of air and because of convectional currents. But there is no convectional current and no mixing of air in stratosphere. That is why the ozone layer in stratosphere is more permanent. The second reason is that the intensity of solar radiation, for photolysis is very less in case of troposphere when compared to stratosphere. Clear? Sterilizing agent means that it is used for making the water germ free. Now, intensity of solar radiation for photolysis is less in case of troposphere when compared to stratosphere. And as far as the third reason is concerned, we can see the third reason is that stratosphere is a dry region. So, we can say that stratosphere is a dry region and troposphere is a region where moisture is present. The troposphere is a region where moisture is present and ozone happens to be unstable for moisture. So, we can find three reasons why ozone layer is confined to stratosphere and not present in troposphere. Clear? But if a question is asked like this, that ozone on account of its location is both beneficial and harmful for mankind, we can see yes, because ozone when it is present in stratosphere, it is ozone when it is present in stratosphere, it is what? It is beneficial for us. Why? Because it is responsible for what? It is responsible for filtering the harmful UV radiation. Filtering the harmful UV radiation. And when you are talking about UV radiation, we can see UV radiation is of three types. When we are talking about UV radiation, we can see UV radiation is of three types. First is what? First is UVA. So, this is UVA. Now, we can see UVA is not at all hindered by the ozone layer. We are saying that UVA is not at all hindered by the ozone layer. And why we are saying UVA is not at all hindered by the ozone layer? Because UVA radiation strikes the surface of the earth naturally. So, it is striking the surface of earth naturally, it is not at all obstructed by the ozone layer. Clear? Not at all obstructed by the ozone layer. And if you look at the wavelength of this radiation, the wavelength of this radiation is from 320 to 400 nanometers. And definitely it is coming to the surface of the earth, it would be responsible for some adverse impact. It is responsible for aging. Aging means that when it falls on the skin, the elasticity of the skin would be getting reduced. So, it is responsible for aging process. Clear? It is responsible for aging process. But on the other hand, when we are talking about the second kind of UV radiation, see, UVA won't be a matter of concern for us. And why it won't be a matter of concern for us? Because it is coming to the surface of the earth naturally, falling on the skin naturally. So, it is not a matter of concern, but the adverse impact certainly is aging, and aging is an adverse impact, and it is why? Because the elasticity of the skin is getting reduced. But when you talk about UVB radiation reaches the surface of the earth in negligible amount, in negligible amount. Clear? And we can see that it's a matter of concern, because if ozone layer gets depleted, then more and more of UV radiation would be coming to the surface of the earth. And the wavelength of this radiation is from 290 to 320 nanometers. And this radiation would be responsible for damaging impact. Why? Because it is responsible for cataract. It is responsible for skin cancer. So, these kind of damaging impact can be seen due to UVB radiation. But the third kind of radiation is called as UVC radiation. And UVC radiation does not reach the surface of the earth. Now, it is not reaching the surface of the earth and completely hindered by the ozone layer. It can only reach the surface of the earth when there is no ozone layer, and this cannot happen. Because if sunlight is present, in oxygen is present, UV radiation, ozone would be formed. Ozone would be formed. The thing is that ozone is continuously being formed only, but the rate of formation of ozone is less than the rate of its depletion. Clear? The rate of formation of ozone is less. So, how can you stay away from UVA radiation? Because that's reaching the surface of the earth naturally. Now, we can see that if the ozone would be formed also, but the rate of formation of ozone is less than the rate of its depletion. That's why we can see that ozone layer depletion is reported, ozone hole is reported. There is no hole as such, only the thickness of the ozone layer reduced is called as ozone hole, and the lambda of this radiation is what? 100 to 200, 290 nanometers. But if suppose only if this strikes the surface of the earth, anyhow if it strikes, although it won't be striking, if it strikes the surface of the earth, it would be doomsday for mankind. Damage. Why? Greater damage. Why? Because this would be responsible for tissue damage to humans. So death for humans would be taking place. Clear? No, these are not alpha and gamma and beta radiation, because alpha, gamma and beta radiation are emitted from radioactive substances. Clear? Now this is, now suppose if a question is asked to you, which UV radiation is a matter of concern in limelight of depleting ozone layer, it would be what? It would be UVB. And if a question is asked that which UV radiation is reaching naturally the surface of the earth, it would be UVA as such. And also suppose the question comes like this, that energy is inversely proportional to wavelength. If we see energy, wavelength is decreasing, but more damaging is the impact. Clear? Wavelength is decreasing, but more damaging is the impact. So we can say energy is inversely proportional to wavelength. So wavelength is decreasing, more energetic is the impact as such. Now we say that when ozone layer is present in stratosphere, it is beneficial for us. And why it is beneficial for us? Because it is responsible for filtering the harmful UV radiation. Clear? It is responsible for filtering the harmful UV radiation. That's why we say that this is beneficial for us. Clear? But when we are saying that ozone on account its location can be both beneficial and harmful for mankind, remember that if ozone is present in troposphere, it would be harmful for us. And why it would be harmful for us? Because tropospheric ozone is nothing but a type of pollutant. Clear? When we are talking about tropospheric ozone is nothing but a type of pollutant. Why? Because if you talk about O3, ozone has been included as one of the indicators in the National Air Quality Index of India. That's one thing. Second is, ozone is not only a pollutant in the National Air Quality Index of India, but we can see that ozone is also part of what? It is also part of photochemical smog. Photochemical smog is what? Photochemical smog is secondary air pollutant. So it happens to be a part of photochemical smog. And third is what? That when you talk about tropospheric ozone is dangerous for us, tropospheric ozone is dangerous for us. From where do we get tropospheric ozone? We get tropospheric ozone from where? The sources of tropospheric ozone includes what? It includes first oxidation of methane. So when you are talking about that tropospheric ozone is dangerous. Why dangerous? Because it is acting as what? It is acting as a pollutant and has been included in the National Air Quality Index. Tropospheric ozone is dangerous. Why? Because it is a part of photochemical smog also. That is the secondary air pollutant. And tropospheric ozone is dangerous also. Why? Because it is formed how? It is formed due to oxidation of methane. Formed by oxidation of methane. So if oxidation of methane takes place, then tropospheric ozone would be formed. It is also formed how? It is also formed due to oxidation of benzene. Oxidation of benzene. So oxidation of methane, oxidation of benzene is responsible for formation of what? It is responsible for formation of tropospheric ozone. Clear? Responsible for formation of tropospheric ozone. Then tropospheric ozone also can be formed from where? It can be formed from dust storms. Dust storms in the northern part of India come from the Arabian Peninsula, come from the Thar Desert, and they are responsible for what? They are responsible for I'll explain just now, don't worry. See, there is no hole as such. The thickness of ozone layer is measured in a unit which is called as Dobson unit. UVC radiation does not strike the surface of the earth because it can strike the surface of the earth if no ozone layer is present. That cannot happen. And before that happens, we are going to die because ozone would be formed always if oxygen and O3, ozone would be formed always if oxygen and sunlight is present. Clear? And without any one of them, we are going to die. Fine. So ozone would be always formed. And this is why we say that UVC radiation won't be reaching there because it can reach the surface of the earth if there is no ozone layer, which is not at all possible as such. So we cannot say so that this would be coming to the surface of the earth. When there is no ozone layer. And as far as, yes, photochemical smog. I'll explain photochemical smog in brief. Dust storms are also responsible for enhancing the tropospheric ozone. Dust storms also enhance the level of PM 2.5, PM 10. So these are the sources of what? Sources of tropospheric ozone, which hardly has been mentioned in the books also. Now see, photochemical smog means what? That if suppose industrial emission takes place, and vehicular emission takes place on a large scale, and particularly in some parts of the metropolitan cities, vehicular or industrial emission would be very high. See how CH4 is formed. CH4 has many sources. CH4 is formed from coal mines. CH4 is from gas hydrates. It's present in shale gas. It's emitted from paddy fields. There are many sources. It's emitted from water reservoirs. Ozone formed by methane oxidation. Can we say global warming has effect in tropospheric ozone but not ozone hole? Yes, you can say that. And lastly we'll relate that to it also. So if suppose we are talking about industrial emission or vehicular emission, which is in some part of the city more, and some part of the city more because of traffic congestion also it can be, so industrial and vehicular emission is more and more. Due to industrial and vehicular emission, what is pumped into atmosphere is NOx, that is oxide of nitrogen, plus hydrocarbons. So when sunlight acts on NOx, that is oxides of nitrogen and hydrocarbon, we can see three things would be generated. One is what? One is nitrogen dioxide. Second is O3. And third is peroxy, acetyl nitrate. That's called as PAN, peroxyacetyl nitrate or PAN. In a combined form, they would be called as what? They would be referred to as photochemical smog. So we are saying that in a combined form, they are referred to as what? They are referred to as photochemical smog. So this is photochemical smog. If the intensity of solar radiation is higher, then photochemical smog is called as what? It is called as brown air. If the intensity of solar radiation is low, then it is referred to as what? It is referred to as grey air. So there are two names of photochemical smog based on intensity of solar radiation, and photochemical smog has O3 present in it. We can see that the O3 which is present in photochemical smog, oxidant which is present in photochemical smog, certainly this oxidant which is present in photochemical smog is acting as a part of secondary air pollutant, and ozone itself is a primary air pollutant also. So all these things that you have to know. So ozone on account of its location can be both beneficial. If it is present in suppose stratosphere, it is beneficial for us, and if it is present in troposphere, it is harmful for us. And we can see the sources of tropospheric ozone include many. Clear? Sources of tropospheric ozone includes many. ठीक है, fine. Let's see the question. Ozone formed by methane oxidation, can we say global warming has an effect? Yes, it can be said. Now, let's move. In 1985, for the first time, ozone depletion was reported for the first time over Antarctica. Antarctica. Ozone depletion was reported for the first time over Antarctica. The 19. Now, शुभ यादव, स्टडी क्या इतनी इकोलॉजी एंड एनवायरनमेंट यूपीएससी के प्री के लिए काफ़ी है? अभी मैंने कंप्लीट नहीं किया है बेटे, मुझे कंप्लीट करने दो। अभी मात्र 20-30% हुआ है। इतनी मत कहो इसे। अभी मैंने ये नहीं कहा है कि इतनी है ये, बिकॉज दिस वुड बी सर्टेनली गोइंग ऑन। अभी ये पूरा नहीं हुआ है, अभी तो मैं एक ही चैप्टर शुरू किया हूँ जो फेमस टॉपिक्स में है, ओजोन लेयर। यूपीएससी पढ़ाई खोजती है बच्चे, हम लोग ट्राई कर रहे हैं कि मैक्सिमम आपको कवरेज दे दें, कंटेम्प्रेरी का भी और ये भी। क्लियर? तो ये पढ़ाई खोजती है, और आज देखो मैं कितना तुम्हें कर सकता हूँ। सी बोथ इट इज़ प्राइमरी ऑल्सो एंड सेकेंडरी। देखो प्राइमरी इसलिए होगा ना क्योंकि वो नेशनल एयर क्वालिटी इंडेक्स का एक इंडिकेटर है, और सेकेंडरी इसलिए होगा कि वो फोटोकेमिकल स्मॉग का पार्ट है। क्लियर? इतना नहीं, अभी तो मैंने शुरू ही किया है शुभ यादव, अभी आई हैव जस्ट स्टार्टेड। प्लीज थोड़ा सा भी लेट्स कंटिन्यू। ये इतना नहीं है, आई एम नॉट कंप्लीटिंग। अभी ये चलेगा 12 बजे रात तक, उसके बाद फिर बायोटेक्नोलॉजी चलेगा बच्चों। मैं आया हूँ तो आपके कष्ट के निवारण के लिए। तो आप ये मत सोचिए कि बस इतना ही आएगा, अभी तो ये स्टार्ट ही हुआ है। क्लियर? सी इन 1985 we can see ozone depletion was reported for the first time over Antarctica. And if we talk about the thickness of ozone layer over Antarctica in 1950s, it was from 280 to 320 Dobson unit, which in 1985 reduced to 136 Dobson unit. So that was a drastic reduction. And this was reported for the first time. Ozone depletion was reported for the first time. Now, as far as this depletion is concerned, ozone layer depletion is concerned, now we can say that 1950s 280 to 320 Dobson unit to 136 Dobson unit. So it was reported for the first time. मूवी लंबी है अभी, यस मूवी लंबी है बच्चों, प्लीज़ थोड़ा शेयर करो आज और आराम से पढ़ो इसे, ठीक है? ठीक है, जस्ट इसको अभी थोड़ा सा अभी एक्सपैंड करो, इसमें बहुत सारी चीज़ हैं, ठीक है? तो थोड़ा से कवर करने दो इसे। So it reduced to 136 Dobson unit. अब ये कहते हैं कि what are the ozone depleting substances? So when we talk about the ozone depleting substances, जिसको हम लोग कहते हैं क्या? ODSs. Ozone depleting substances includes many CFCs, chlorofluorocarbon, nitrous oxide, methane, then also HCFCs, So all these are what? All these are ozone depleting substances. Clear? All these are ozone depleting substances and these are present for ozone depletion. When you are talking about CFC, chlorofluorocarbon, CFCs are never directly responsible for ozone layer damage. See, CFCs are never directly responsible for ozone layer damage, but they emit chlorine which is responsible for doing so, and this chlorine would be combining with O3 to form ClO plus O2. So you can see this ClO is responsible for the damage. This ClO is responsible for the damage. Clear? And in this reaction, we can see ClO would be again combining with O3 to form Cl plus 2O2. So Cl is again formed also. Clear? Cl is again formed also. So they are never directly responsible for ozone layer damage. They are never directly responsible for ozone layer damage. Fine. But they emit chlorine which is responsible for doing so. Fine. Now see, chlorine which is responsible for doing so. Now the thing is what? That maximum damage to ozone layer is not done by them. Maximum damage to ozone layer is done by 4 free radical catalysts. And the 4 free radical catalysts include what? It includes chlorine, it includes bromine, it includes hydroxyl, it includes नाइट्रिक ऑक्साइड. These 4 free radical catalyst, ये 4 free radical catalyst हैं. Free radical catalyst which is responsible for maximum damage to ozone layer. Which is responsible for maximum damage to ozone layer. Yes, carbon monoxide for ground level ozone. Fine. Let's continue. Now, in all these 4 free radical catalysts that we have discussed, maximum damage would be done by whom? Maximum damage is done by bromine. इन चारों में सबसे ज़्यादा डैमेज कौन करता है? ब्रोमीन. But the problem is what? That bromine is never found in free state in atmosphere. So the problem is what? That bromine is never found in free state in atmosphere as it is highly soluble in water. Clear? So we can extract brominated compounds. Brominate के compounds जो है ब्रोमीन के वो एक ही जगह से extract कर सकते हैं. कहाँ से? ब्राइन पूल. अब ब्राइन पूल का मतलब नहीं कि ओशियन के अंदर जाके इसे एक्सट्रैक्ट किया जाएगा. ब्राइन पूल इनलैंड भी होते हैं, जैसे सांबर लेक इज अ ब्राइन पूल इन जयपुर. So it can be extracted from their Sambar lake. So it can be extracted from there. So it can be extracted from brine pools. Clear? It can be extracted from brine pools. But इसे use कहाँ करेंगे? Where is brominated compounds used? Now brominated compounds, bromine के जो compound है, brominated compounds are used for what? It is used as a fire retardants. See, there is one term which is called as fire extinguisher. So fire extinguisher means that they are responsible for extinguishing the fire. But when we are saying fire retardants, now that means that they are responsible for what? They are responsible for retarding the fire, suppressing the fire. So when brominated compounds are used as fire retardant, they are called as what? They are called as BFRs. That is brominated fire retardants. But in UPSC we can see that they have asked you what? They have asked you that what are the adverse impact of BFR. So the adverse impact of BFR include what? The adverse impact of BFR include that they are bioaccumulative in nature. So they are bioaccumulative in nature. So they enter the food chain, and they are also what? They are also endocrine disruptors. endocrine disruptors. So they are bioaccumulative in nature and also act as endocrine disruptors. One compound of bromine was used as what? Used as a pesticide in agriculture also. For example, that compound was what? That compound was methyl bromide, was used as a pesticide in agriculture. But it was responsible for damaging the ozone layer also. So WHO took a note of it, and WHO was responsible for banning the use of methyl bromide in agriculture. So it has been banned, and we can see that methyl bromide was is present as a class 1 ODS. Class 1 ODS means that it would be damaging the ozone layer to a greater extent. So it is present as a class 1 ODS in the Montreal Protocol and should be phased out immediately. Clear? So methyl bromide is what? Methyl bromide is a type of what? Brominated compound which was used as a pesticide in garden, in agriculture as such. It has been banned. So they have asked you about the adverse impact of brominated fire retardant. See, BFR is present where? BFR is present in the electronic devices that you use. Laptops, mobiles. BFR is present in the furniture. BFR is present in the smart boards. BFR is present in the plastic components. So all these would be having BFR in large numbers. Clear? All these are having BFRs in large numbers. Now, we know that damage to ozone layer is more in Antarctica. See, if we suppose we consider that in tropical areas, industrialization, tropical areas of northern Europe, of northern hemisphere, not northern Europe, of northern hemisphere, industrialization is maximum. But damage to ozone layer takes place where? Damage to ozone layer takes place mainly in Antarctica. Mainly in Antarctica. So what are the factors which are responsible for that? If we are saying that here the industrialization is maximum, but damage to ozone layer takes place mainly here, Antarctica. So what are the factors which are responsible? The factors which are responsible for this include shape of the earth. Shape of earth. The factors which are responsible for it include what? It also includes the rotation of earth. The rotation of earth. And factor which is responsible for it also includes the lowest temperature of, low temperature of Antarctica. Low temperature of Antarctica. So here what happens that when the industrial emission rises in the tropical areas of northern hemisphere. Here suppose the industrial emission is rising in the tropical areas of northern hemisphere. What is happening? They are combining with the cold stratospheric air. See, the hot tropospheric air we say why, and cold stratospheric air we say why. Hot tropospheric air, it is said why? Because it is responsible for absorbing the infrared radiation. Clear? And shape of earth, rotation of earth and lowest temperature. And we can see, yes, now we can see that temperature of stratosphere is low. Why? Because the infrared radiation is more absorbed in troposphere due to emission of more and more of greenhouse gases. And it is less present in the escape of infrared radiation is less in what? It is less in stratosphere. That's why stratosphere becomes cooler. So we are saying that when the hot tropospheric air in the tropical areas of northern hemisphere mixes with the cold stratospheric air, just like a convectional current, a circulation is generated which is called as what? Which is called as Dobson-Breuer circulation. Dobson-Breuer circulation. Just like a convectional current, a circulation is generated which is called as Dobson-Breuer circulation. Now this circulation would be responsible for carrying the emission towards the poles. This circulation is responsible for carrying the emissions towards the poles. So we can see the industrial emission which is carried by the hot tropospheric air has mingled with the cold stratospheric air, and just like a circulation, convectional current, Dobson-Buer circulation is generated, which is responsible for pushing the emission towards the poles. Clear? The emissions are getting accumulated near the poles. They are getting accumulated near the poles. And the reason for this is what? The reason for this is the nearer center of gravity. Suppose we take the equator here, and here is the center of gravity. Suppose this is a circle inside, and here is the center of gravity. So we can see the shape of the earth is what? It is geoid. The shape of the earth is what? It is oblate spheroid. So it is due to nearer center of gravity, what is happening, that the industrial emission is getting accumulated near the poles. Clear? Industrial emission is getting accumulated near the poles. And as the earth rotates, formation of vortex wind takes place here. So when the industrial emission has got accumulated near the poles, it is now rotating along with the vortex wind. And industrial emission consists of what? It consists of ODSs. It consists of what? It consists of ozone depleting substances. So as the earth rotates, this vortex, the wind which is formed, now industrial emission which has been trapped here would be now rotating along with the vortex. And what happens, that this vortex wind would be condensing when winter comes to form highly reactionary clouds. Now these highly reactionary clouds would be called as what? It is called as polar stratospheric clouds. So I am saying that first of all, industrial emission got accumulated here, and industrial emission has got accumulated here. So they are now rotating along with the vortex wind. And when the winter falls, when the winter comes, the vortex wind would be condensing to form a highly reactionary cloud. And this highly reactionary cloud is called as what? This is referred to as the polar stratospheric clouds. And let's see why we are saying that it is highly reactionary in nature. So this is called as polar stratospheric clouds. Now nothing will happen during winter. No, nothing will happen during winter. But when the winter gets over and solar radiation again reaches this area, then ozone depletion would take place. Remember two things, that ozone depletion would be taking place if two conditionalities are met. Clear? I am saying that ozone depletion would be taking place if two conditionalities are met. The first conditionality is ozone depletion takes place at low temperature. And the second conditionality is what? That ozone depletion would be taking place only in the presence of sunlight. Because sunlight is responsible for triggering the ozone depletion reaction. The ozone depletion reaction cannot get triggered without the sunlight. So sunlight is always responsible for triggering the ozone depletion reaction. And in winter, there is no sunlight in the polar areas. Clear? So when the winter, that's why we are saying that no activity would be taking place during winter. But when winter gets over and solar radiation again reaches this area, now the solar radiation would be falling on the PSCs, and from the PSCs, we can see that ozone depleting substances would be emitted. So here we are saying that solar radiation is falling on the PSCs, and from the PSCs, ozone depleting substances are emitted. ODSs are emitted. And ODSs would be emitted from where? ODSs would be emitted from the icy layers of PSCs. ये देखो, ये PSCs है ना, तो इसमें ice के layers हैं. Now इस icy layers से ozone depleting substances निकलते हैं. Now एक तो ओजोन डिप्लीटिंग सब्सटेंस निकल रहे हैं इस आईजी लेयर से. क्लियर? क्योंकि यहीं वो ट्रैप थे. सेकेंड इज व्हाट? दैट दीज आईजी लेयर्स आर एक्टिंग एज व्हाट? दे आर एक्टिंग एज अ प्लेटफॉर्म फॉर ओजोन डिप्लीशन रिएक्शन टू अकर. यही प्लेटफॉर्म है because this is providing the low temperature. The icy layer is providing the low temperature. So, it is acting as a platform for ozone depletion reaction to occur. And the target is also nearby, that is ozone layer, because this is present where? In the stratosphere. So, the target is also nearby the ozone layer. So, we can say what? We can say that the source is present there only, the target is also present nearby, and that is why damage to ozone layer takes place more during this period, because the icy layers of PSCs is not acting only as a source of ODS, but also they are acting as what? They are also acting as a platform for ozone depletion reaction to occur. Clear ozone depletion reaction to occur. So, that is why we are saying that ozone damage. But then if this be the case, then damage to ozone layer should have been in an identical manner in both the Arctic region and Antarctic region, but that does not happen. Damage to ozone layer takes place more and more when? More and more in Antarctica. And the reason for this is that in winter the temperature of Antarctica can dip down to minus 115 degrees centigrade. In winter, the temperature of Arctic region can dip down to what? It can dip down to minus 60, minus 70 degrees centigrade. Clear? So, in case of Antarctica, the icy layers of PSCs would stay for a greater period of time, and damage to ozone layer in Antarctica would have been more when compared to Arctic region. Clear? Damage to ozone layer in Antarctica would be more when compared to Arctic region. So, we can see there are three reasons for depletion of ozone layer in Antarctica. One is the shape of the earth, and shape of the earth is why? Because it is the shape of the earth which is responsible for the industrial emission to get accumulated in the polar areas due to nearer center of gravity. Second is what? Second is the rotation of earth. It is the rotation of earth which is responsible for what? It is the rotation of earth which is responsible for formation of vortex wind. And third is lowest temperature of Antarctica, because it is the lowest temperature of Antarctica which is responsible for what? The icy layers of PSCs staying for a greater period of time in Antarctica. Clear? Greater period of time in Antarctica. Clear? Yes, I think that is clear. Now, Subhi, I have repeated these things cannot be repeated again because it will take time. But see, one more, two things here needs to be done. In the year 2021, there was a report published by Lancaster University. Lancaster University is in UK. And this report says that global warming is related to ozone layer depletion in more than one way. Clear? Global warming is related to ozone layer depletion in. Now, Coriolis force is maximum, that's yes. But it's related to ozone layer depletion in more than one way. Now, what is the basis of this? The basis of this is what? They are responsible for drawing few connects. Now, the first connect that they have drawn is what? The first connect they are responsible for drawing is what? That when we talk about ozone layer and global warming, ozone layer depletion and global warming, we can see all ODSs are greenhouse gases. पहली चीज उन्होंने क्या कहा कि जितनी भी ओजोन डिप्लीटिंग सब्सटेंसेस हैं सारे के सारे ग्रीन हाउस गैस है, और O3 खुद ही एक ग्रीन हाउस गैस है. Ozone itself is a greenhouse gas. Clear? So, first connect drawn was this. The second connect is what? When you are talking about ozone layer depletion, देखो ozone layer depletion का एक और क्या है adverse impact, खास करके UVB radiation का. UVB radiation क्या करते हैं? UVB radiation is reaching the surface of earth. Clear? Is reaching the surface of earth. So, when UVB radiation is reaching the surface of the earth, it is responsible for what? It is responsible for damaging also phytoplanktons. ये नहीं है कि सिर्फ cataract और skin cancer होते हैं. It's also responsible for damaging what? It is also responsible for damaging phytoplanktons. अगर मान लो UVB radiation phytoplankton को damage करेगा, what will happen? Phytoplankton damage means that the carbon sink is getting reduced क्योंकि phytoplankton is absorbing CO2 for photosynthesis. Oceans जो absorb करती है CO2 वो तो utilize होता है phytoplankton algae में. So if phytoplankton is getting damaged, yes, Arctic amplification also in news. We'll try to cover up. We'll try to cover up. Arctic Council will cover up. Clear. Now, when we are talking about this, that phytoplankton is getting damaged. Now, phytoplankton getting damaged means, now, just before going into the break, we were responsible for discussing that a report was published in 2021 by Lancaster University, and that report said that ozone layer depletion is related to global warming in more than one way. See, filling of ozone layer has already started, because ozone depletion is not as today as it was in the year 1985 or 1986. But this report, Lancaster University report, stated that ozone layer depletion is related to global warming in more than one way. And the first connect which was drawn was that when we talk about ozone layer depletion, all ODS are greenhouse gases also. Even I said that O3 is a greenhouse gas. Then we can see that not only O3 is a greenhouse gas, but all ODS are greenhouse gases. The second connect which was drawn in the report was that if suppose ozone layer depletion takes place, more and more of UVB radiation would be reaching the surface of the earth. And if more and more of UVB radiation reaches the surface of the earth, then more and more of UVB radiation reaches the surface of the earth, then we can see that it would be also responsible for destroying the phytoplanktons. And phytoplanktons are what? Phytoplanktons are carbon sinks. They are responsible for absorbing CO2 from atmosphere. Because when we say oceans absorb, it's mainly the phytoplankton which is responsible for absorbing, or algae which are responsible for absorbing. So they are responsible for absorbing CO2 from the atmosphere. And when the carbon sinks would be reduced, like phytoplankton is getting damaged, carbon sink is reduced, it means that the CO2 level in atmosphere would be enhancing. This would be further aggravating global warming. So ozone layer depletion is responsible for further aggravating global warming. That's one thing. And on the other hand, we can see that as far as phytoplanktons are concerned, we can see also that the third thing which was responsible, that we said that as far as the third connect is what? The third connect is that when we are talking about ozone layer depletion, that ozone layer depletion takes place, global warming takes place. Global warming is responsible for what? Global warming is responsible for enhancing the temperature of troposphere, but it also reduces the temperature of stratosphere. Clear? Why? Because the escape of infrared radiation in stratosphere would be reduced. So it is responsible for enhancing the temperature of troposphere, but it also reduces the temperature of stratosphere. And we can see that this would be affecting, this would be further responsible for what? Further responsible for ozone layer depletion. Why? Because reduction in temperature of stratosphere is responsible for ozone depletion in two ways. One, low temperature is conducive for its depletion, that's one thing. And second thing is what? Second thing is that formation of PSCs takes place at minus 76 degrees centigrade. So formation of PSCs takes place at minus 76 degrees centigrade means what? If we are saying that formation of PSCs is taking place at minus 76 degrees centigrade, it means that this condition would be rendered by Antarctica more when compared to Arctic region. Clear? This condition would be rendered by Antarctica more when compared to Arctic region. So this is how we are saying that ozone layer depletion is related to global warming in more than one way. Is that clear? Ozone layer is related, depletion is related to global warming in more than one way. But also do remember that when we are talking about spring in Antarctica, if we talk about the spring in Antarctica, when spring takes place in Antarctica, from the stratosphere, from the Antarctica, from the polar regions, during spring in Antarctica, from Antarctica, this area, the polar stratospheric air would be moving outward. And when the polar stratospheric air moves outward, it has ozone depleted within it. So the nearby countries are responsible for issuing what is called as UV alerts. Why? Because it has ozone depleted within it. So nearby countries would be responsible for issuing UV alerts. But in Arctic region and Antarctic region, we can see that in Arctic region or even in Antarctic region, we can see that as far as ozone layer is concerned, there is a type of forecast also maintained. And this forecast is a daily forecast of UV exposure, which is called as UV index. So the scheduling, programming is done according to this forecast, which is called as what? Which is referred to as UV index. Clear? Which is referred to as UV index. So this also you have to know. One is called as UV alert and second is called as UV index. Now, if we talk about the adverse impact of ozone layer depletion, the adverse impact of ozone layer depletion includes what? It includes in skin cancer, it includes cataract, it includes skin cancer, cataract, it also includes damage to immune system, that's also another. It also includes damage to nucleic acid, damage to immune system, damage to nucleic acid. It also reduces photosynthesis performed by phytoplankton. So all these are adverse impact of ozone layer depletion. Clear? Adverse impact of ozone layer depletion. But when we are talking about ozone layer depletion, we can see that many steps have been taken. In 1985 itself, when ozone depletion was reported for the first time, 1985 itself, when ozone depletion was reported for the first time, an initiative was taken, and that initiative was that Vienna Conference was organized. Vienna Conference was organized in 1985 itself. And the purpose of organizing Vienna Conference was to study the impact of anthropogenic activities on ozone layer, that how depletion has taken place, that what are the impact of anthropogenic activities on ozone layer. So that was done in 1985. But also we can see that concrete steps were taken in 1987. And these steps were taken in 1987 when Montreal Protocol was organized. Montreal Protocol was organized. And Montreal Protocol was signed by 27 nations. Now, India was not among the 27 nations which signed the Montreal Protocol. So, it was signed by 27 nations. India became a signatory later on, but at that time, India was not a signatory to sign the Montreal Protocol. And we can see that as far as Montreal Protocol is concerned, Montreal Protocol is for what purpose? The purpose of Montreal Protocol is to limit the production of ODS, to limit the production of ODS. And second purpose is to phase them out. Now, for phasing them out, we can see there were two time frames suggested. Time frames. One was for developed nation, means developed nation, they have a shorter time frame to remove the ODSs, to remove the ozone depleting substances. But a longer time frame was set up for what? A longer time frame was set up for the developing nations. Clear? So, longer time frame was set for developing nations. They were given some time that they should be responsible for In 2011 paper, option with global warming as reason for ozone layer depletion was wrong. Now after this report, do we say that this is correct? Yes, it is correct. Yes, it is correct. Sometimes the UPSC question are wrong also. You can see the question I give you. That earlier they have asked you the source of CFC in UPSC, and in answer they have given you tubeless tire as wrong option. Clear? But tubeless tire is a source of CFC. Tubeless tire is nothing but plastic foam, and plastic foams are source of, they are made up of natural and synthetic polymer, which are nothing but plastic foams. Clear? Fine. So please, now the things would be changing because you have all the connects. You have all the connects. Now we can see that longer time frame was given for developing nation and a shorter time frame was given for developed nation, that they have to remove the ODSs. And plus we can see ODSs were also classified. ODSs classified means that they were put into different categories. ODSs were classified, put into different categories, that is class 1 ODS, class 2 ODS. For example, suppose when you are talking about methyl bromide, methyl bromide is what? It is a class 1 ODS. Methyl bromide is a class 1 ODS. Clear? So it's a class 1 ODS. Fine. Now, we can see that India was not a signatory to Montreal Protocol earlier because India believes in certain principle. India believes in what is called as polluter pays principle. Polluter pays principle means what? Polluter pays principle means that when you are talking about atmosphere of the earth being polluted, it was mainly polluted by developed nation. So developed nation under their colonial imperial rule were responsible for polluting the atmosphere of the earth. We are not responsible for doing that. So they have started the fire. And if suppose we are pressurized to take initiative for mitigating the adverse impact of global warming and climate change, mitigating the adverse impact of global warming and climate change, the funding should come from where? The funding should come from developed nation. Clear? So that's called as polluter pays principle, because if we direct our fund for mitigation measures, then our development process would be impeded. The second principle on which we adhere is called as what? Is called as ecological depth. Ecological depth means that during the colonial imperial rule, what happened was that our resources were utilized by whom? Our resources were utilized by the developed nations. So it's now the time for the developed nation to pay it back to us. So that's called as ecological depth. And the third principle to which India adheres is called as what? It is called as CBDR. CBDR stands for common but differentiated responsibility. So common but differentiated responsibility means what? It means that both industrialized nation and developing nation have the same objective. The objective is to reduce the adverse impact of global warming and climate change. The objective is to reduce the adverse impact of global warming and climate change. But then the responsibility should be more shouldered by the developed nation when compared to developing nation. Clear? So responsibility should be more shouldered by the developed nation when compared to developing nation. Now, as far as Montreal Protocol is concerned, our position was that we believe in polluter pays principle. So we were not responsible for signing it earlier, but we became a signatory later on. But we can see that after this, in the year 1990, a UN conference was organized. And this, under this UN conference, a fund to the tune of $240 million was constituted. And this was constituted to help the developing nations find alternatives for CFC. So this was constituted to help the developing nations find alternatives for CFC. The alternative for CFC was found in the form of what is called as HFC. Clear? And this was now used in air conditioners. HFCs were used in air conditioners. Now HFCs are less damaging to ozone layer, when compared to CFCs. When we are talking about HFCs, we can see HFCs are less damaging to ozone layer when compared to CFCs. But HFCs have a very high heat retention capacity. The heat retention capacity of HFCs is 1000 times than that of CO2. Clear? And that's why we can see that it would be responsible for aggravating global warming to a greater extent. Clear? So, as far as the heat retention capacity is concerned, if suppose they ask you the heat retention capacity of water vapor, that is, we are saying that heat retention capacity of water vapor is twice than that of CO2. Twice than that of CO2, double than that of CO2. But you know that water vapor is short-lived in atmosphere. Then we can see the heat retention capacity of methane, CH4, is 25 to 28 times than that of CO2. 25 to 28 times than that of CO2. Then we can see the heat retention capacity of HFCs, which was used in air conditioner instead of CFCs, is 1000 times in that of CO2. So, this is the heat retention capacity. Heat retention capacity that we are talking about. That's the heat retention capacity. And we can see also that Teflon is produced. Yes, that fund was Global Environmental Facility. Now, we can see that this heat retention capacity, also we can see that there is a substance called Teflon, which is used in non-stick wares. And this, when it is produced, when industrial manufacturing of Teflon takes place. Industrial manufacturing of Teflon takes place. Then as a byproduct, a substance is produced which is called as fluoroform. So, this is a byproduct which is produced in the industrial manufacturing of Teflon. So, this byproduct CHF3 it is called. So, if we talk about 1 ton of CHF3, it is equivalent to 11,700 tons of CO2. So, the heat retention capacity of CHF3 is very high, followed by HFCs, followed by methane and followed by water vapor. Clear? But these are what? These are short-lived in atmosphere, all these three. CO2, when we say CO2 is long-lived in atmosphere because it stays in atmosphere for 120 to 200 years, CO2. And as far as methane is concerned, methane is short-lived in atmosphere because it stays in atmosphere for 9 to 12 years. And all these are short-lived in atmosphere, but CO2 is long-lived in atmosphere. That's the heat retention capacity, and that's why HFC was a concern. Yes. See, remember two time periods. One is of CO2, which is 120 to 200 years. Second is of methane, which is of 9 to 12 years. But as far as HFC is concerned, it is also short-lived in atmosphere. It resides in the atmosphere for less than 10 years. Clear? Black carbon is also a short-lived in atmosphere because it is residing in atmosphere for less than 7 to 9 years it resides. That's the time period. HFC is for short or long. It's for short. Clear? And that's why we say that there was an agreement also signed, if you remember in some books you would have read, that is called as what? That is called as Climate and Clean Air Coalition. Climate and Clean Air Coalition. And what is Climate and Clean Air Coalition? This coalition was signed in the year 2012, and the purpose of Climate and Clean Air Coalition to phase out short-lived pollutants in atmosphere. The purpose of Climate and Clean Air Coalition was to phase out short-lived pollutants in atmosphere. And these short-lived pollutants in atmosphere include mainly three. And that's why we are saying HFCs, black carbon and methane. So these are short-lived pollutants in atmosphere. This agreement was signed by six nations, which included US, Canada, Mexico, Ghana, Sweden and Bangladesh. So there were six nations which were responsible for signing the Climate and Clean Air Coalition. Climate and Clean Air Coalition. See, yes, sulfur hexafluoride is longest and is most adverse. That's why sulfur hexafluoride is recognized as a greenhouse gas under the Kyoto Protocol also. And sulfur hexafluoride is also emitted from where? It is emitted from solar waste. Clear? So it is emitted from solar waste. It is used, sulfur hexafluoride is also used for electronic components. So it is emitted from solar waste. Fine. Now, see, that's called as Climate and Clean Air Coalition. But due to the high heat retention capacity of HFC, it was a grave concern. And it was a grave concern, why? Yes, next to HFC, we are just now discussing. Now, it was a grave concern, why? Because of its high heat retention capacity, because it was responsible for absorbing infrared radiation to a greater extent. So, to phase out HFC, an agreement was signed, and this agreement was called as what? This agreement was called as Kigali Agreement. So, Kigali Agreement was signed in the year 2016, and under this agreement, 90% of HFCs would be phased out by the mid of this century. 90% of HFCs would be phased out by the mid of this century, and this is also based on CBDR. Why we are saying this is based on CBDR? Because the first step would be taken by developed nation. So you can see developed nations like US, Japan would start their initiative first of all. Clear? Then 100 developing nations would do so from 2024, which includes also China. They would start their phasing out program. And then we can see that India, our dear neighbor, Pakistan, Saudi Arabia, all these countries would be starting their phasing out initiative. From where? All these countries would be starting their phasing out initiative from 2028. So that's why we say that this is based on CBDR, common but differentiated responsibility. And as far as HFC is concerned, we can see the alternative for HFC. You can see here also the air conditioner over here, just above me. Now this air conditioner is showing a gas, and that is called as R32. So as a replacement for HFC, we started to use R32. Clear? R32. R32 is called as what? It is called as difluoromethane. Difluoromethane, and this is now used in air conditioners. But the potential is to use other gases also. And the other gases which would be used instead of HFCs, one can be R32 definitely, but the other gases which can be used for HFC instead of HFC include what? It includes R290. This is what? This is propane. This can be used also in air conditioners. R600A, Now 600A is nothing but isobutane. Then we can see R717, and R717 is nothing but ammonia. So these gases also can be used as a replacement for HFCs. Clear? These gases can also be used as a replacement for HFCs. Also, as far as HFC is concerned, remember, as far as CFC is concerned, which was replaced by HFC, we can see CFCs was what? It was a halogenated hydrocarbon because it's a chlorofluorocarbon. It was non-flammable, non-toxic, organic molecules. And generally how it functions, these air conditioners just running on the top. Now, in this, the gas like CFCs or HFCs, they are what? They are nothing but under normal pressure and temperature, they are gas. But if you give them slightly modest of temperature or modest of pressure also, they liquefy. And they liquefy. This liquefaction process is used for what? This liquefaction process is used for the cooling effect. But then the problem is what? That when they are responsible for re-evaporating, they would be absorbing heat. And that's why it's said that, the reason why it is said that greenhouse gases and ODSs, that ODSs are greenhouse gases also. CFC is a ODS because it releases chlorine, which is responsible for damaging the ozone layer. But it is also greenhouse gas because of its high heat retention capacity, because when it evaporates, it would be responsible for absorbing heat also. Clear? It would be responsible for absorbing heat also. And all these are the possibilities of the gas being used. Clear? Now see, as far as yes, we are emphasizing on solar renewable energy to reduce GHG's impact. But solar waste still impact environment, and more than ever are we in vicious cycle of destruction. Yes, solar waste is today a type of e-waste and we are saying that by the year 2050, India would be responsible for generating 1.8 million tons of solar waste, which is a big concern for India, that 1.8. Solar waste, if we talk about solar waste, in solar waste, glass or aluminum is not a consideration for us. That's not harmful as such. But some solar waste are harmful. And this includes what? This includes chromium, cadmium, sulfur hexafluoride. So these happens to be harmful for us. And sulfur hexafluoride, just now we have discussed that it's long lived in atmosphere and has a very adverse impact. Has been recognized as GHG, greenhouse gas, under the Kyoto Protocol, and the source of it is not only solar waste but also electronic devices. Clear? Electronic devices. Some waste will impact, yes. Now, let us solve a question paper here. See, first question, consider the following statements and select the correct code. In the limelight of depleting ozone layer, UVB is a matter of concern, not UVA or UVC as such. We can say yes, it's a matter of concern, because when the ozone layer would be depleting, yes, exactly, from human activities, mainly it is coming from electronic component it comes. It's also emitted from solar waste. Now see, First question, consider the following statement and select the correct code. In the limelight of depleting ozone layer, UVB is a matter of concern, not UVA or UVC as such. Is it correct? Second is energy is inversely related to wavelength. Is this correct? Yes, because we can see the UV radiation, their wavelength was decreasing, but they became more and more energetic as such. UVA radiation is not responsible for any damage. They are responsible for damage because aging is a damage. So, this would be wrong. Aging is a damage. So, we can see 1 and 2 would be the correct answer. Now, consider the following statements and select the correct code. First statement. CFCs are type of halogenated hydrocarbons which are non-flammable, non-toxic organic molecules. So, is that clear? First is correct or not? And second, at room temperature, CFCs are gases under normal atmospheric pressure, but they liquefy under modest pressure. I think first is also correct and second is also correct. Clear? First is also correct and second is also correct. Because CFCs, they liquefy under, and that is used in the cooling process. Clear? So, in case of second, both the options are correct. Now, consider the third question. Consider the following countries: Chile, New Zealand, Argentina, Colombia. Select the correct code of countries where UV alerts are given. Now, tell me. Select the correct code of countries where UV alerts are given. Which is the correct answer? All, B, C or D? Come on, tell me. For answer 3. Answer 3 would be what? It would be 1, 2 and 3 because Colombia is nowhere present near the Antarctica. Clear? So, if suppose UV alerts would be given in those countries where the polar stratospheric air would be moving outward. Clear? So, it would be given in those countries. So, here we are saying that 1, 2 and 3 would be correct because Colombia is nowhere near Antarctica. So, only Chile, New Zealand and Argentina would be the correct answer. During which period of the year ozone depletion would be maximum on Earth? Now, we can see it would be maximum on Earth when? Can you tell me the correct answer for fourth one? What is the correct answer for fourth? The correct answer for fourth would be what? The correct answer for fourth would be C. Because ozone depletion takes place maximum where? It takes place maximum in Antarctica. Antarctica would be witnessing winter when we witness summer. So, spring in Antarctica would be responsible for maximum damage to ozone layer. We are saying that spring in Antarctica would be responsible for maximum damage to ozone layer. And that is why the correct answer would be September, October. Clear? When spring in Antarctica would take place. So, that is your September, October when spring in Antarctica takes place, and that is the correct option. Fine. C would be the correct answer for 4. Yes, Murari Kumar, correct. One mean that's correct. Not D as such, but it would be C. See next question. Which of the following is correct about UV index? Now, correct about UV index is what? It's a daily, that's D. It's a daily forecast of UV exposure. एक मिनट मुझे देखने दो. December sun on Capricorn. See, जब कहते हैं ना कि in Antarctica spring would be witnessed when we have our autumn. Clear? So, in June, July, they would be responsible for witnessing winter. We would be responsible for witnessing summer. After that, in September, October, August, spring would be coming to Antarctica. So it is that time when solar radiation returns back to Antarctica. Then only ozone depletion would take place, and maximum ozone depletion takes place in Antarctica. So that's why we have selected it. Now, as far as 5 is concerned, definitely correct. Okay, 5 is D. It's a daily forecast of UV exposure. Who among the following were awarded Nobel Prize in the chemistry in 1995 for studying CFC's damage to stratosphere? And that was Roland and Molina. That's the first option. Consider the following statements and select the correct code. Major damage to ozone layer has taken place near Antarctica. That's true. Ozone layer is never directly damaged by CFC. That is also true. Methane is also responsible for ozone layer damage. That's also true. So, all the 3 statements of question 7 are correct. Clear? So, and then we can see last, yes, these questions are tough than UPSC. Which one of the following UV radiation is obstructed by ozone layer? Can you tell me which one for 8th? Can you guess? Now, obstructed by ozone layer would be both UV, B and C. As far as question number 8 is concerned, obstructed would be both. Yes, Monu, that's correct. Murari Kumar, that's correct. So, Aditya Jain, correct. Definitely it's D. Because both would be correct. UVC. UVC is reaching the surface of, not reaching the surface of the earth. UVB is reaching the surface of earth in negligible amount. So, largely it is obstructed. Clear? Largely it is obstructed. Now, this is your ozone layer and ozone layer depletion. Let's pick up. Let's pick up a set of question on a recent conducted convention on biodiversity. Clear? Recently, now I'll ask you questions, you will have to tell me the answers. And this is, I haven't taught you, but this is open because this is based on the current issues. So, let's discuss that first of all, and then we'll move forward. See, you can see that the Convention of Biodiversity was recently concluded. Now, you have prepared for preliminary examination, you should be able to solve it. Consider the following, I am putting before you the first question and enlarging it and putting before you the first question. Consider the following statements and select the correct code. Convention on Biodiversity entered into force in the year 1992. Second is signatories to CBD meet every year. The first conference of parties to this convention was held in Bahamas. Now tell me, what is the correct option? And I have some liquid for me. What is the correct option? What is the correct option? The correct option is D. D is not the correct option. D means 1 and 2. C. Yes, C is the correct option. Definitely C is the correct option. Fine. Only 3 would be the correct option. Why? Because Convention on Biodiversity entered into force in the year 1993. Clear? 1992 it was signed at Rio de Janeiro, but it entered into force in 1993. And the signatories to CBD meet every year. They meet every 2 years. When we say COP to CBD would be conducted every 2 years. COP for global warming and climate change is conducted every year. UNFCCC. The first conference of parties to this convention was held in Bahamas. That's true. So only we can see 3 is correct, 1 and 2 are wrong. Clear? 1 and 2 are wrong. Now see, let's try the second one. I am enlarging this question. Second question, which article on Convention on Biodiversity deals with traditional knowledge and benefits sharing? Now tell me, what is the answer? Without looking into the Google. Which article of Convention on Biodiversity deals with traditional knowledge and benefit sharing? Tell me. B. Yes, that's correct. But what are the others doing? D, that's incorrect. C, that's incorrect. The correct answer is what? The correct answer is 8J. That's B. See, when you are talking about Convention on Biodiversity deals with traditional knowledge and benefit sharing. Now, there was a term also which is called as biopiracy. Biopiracy means if the traditional indigenous knowledge of a society or a community has been used for economic benefit without taking the consent of that society and without paying them adequate compensation, then this is called as what? This is called as biopiracy. CBD, Convention on Biodiversity, is responsible for banning biopiracy of any form. So, biopiracy of any form would be banned by it. Now, this article deals with Convention on Biodiversity with traditional knowledge and benefit sharing. Clear? Although CBD has said that biopiracy of any form should be banned. And why biopiracy of any form should be banned? Because at stake is the interest of what? Developing nation. The interest of developing nation is hampered. Clear? That's why we are saying so. Now, next question. Consider the following statements and select the correct code. The Bonn guidelines were adopted at COP6 to the Convention on Biodiversity convened at Netherlands. These guidelines on access to genetic resources and fair and equitable sharing of the benefits arising out of their utilization. Tell me what is the answer for 3. What is the answer for 3? Now, the answer for 3 is what? Both 1 and 2. Both 1 and 2 are correct answer. Clear? None of the above is not correct answer. Both 1 and 2 are correct answer. Now, tell me the next one. With which one of the following Cartagena Protocol is associated? Now, this is very simple. Which of the following the Cartagena Protocol is associated? To protect biological diversity from genetically modified organisms, for sustainable use of biodiversity, access and benefit sharing principle, and access the status of biodiversity, for which it is used. Now, the correct answer is A, to protect biological. So, just remember that Cartagena Protocol is for protecting biodiversity from GMOs, that is genetically modified organisms. So, that's A. Which one of the following statement is incorrect? Nagoya Protocol was adopted at COP10 to the CBD. And then, that's the first. The second statement is Nagoya Protocol deals with access to genetic resources and fair and equitable sharing of benefits arising from their utilization. At the COP10 in Nagoya, countries have agreed to a strategic plan for biodiversity containing 7 targets called Aichi targets. Aichi targets, and Aichi is in the region in which Nagoya is located. Now, the correct answer is what? The correct answer is see, I have said what? Just one thing. See, Bonn guidelines does not mean that the conference would be conducted at Bonn. Sometimes what happens that the country which is holding the presidency of, for example, suppose if you talk about COP23rd of United Nations Framework for Convention on Climate Change. It was convened at which place? It was convened at Bonn, but its declaration is called as Fiji Declaration. Why? Because the country which is responsible for holding the presidency of UNFCCC, in that country only, the COP, Conference of Party annual meet is conducted. But sometimes what happens that for political reason the venue can be shifted. So Fiji in 2023 was responsible for holding the presidency of UNFCCC. But the declaration was called as Fiji Declaration. The conference was conducted at Bonn because of political reasons. That's why it's not essential that Bonn Declaration means that it is convened at Bonn. Clear? Okay. Now, the incorrect answer in this fifth question is, tell me what? The incorrect answer is what? 5. Pankaj Yadav, yes, C. Shivam also C. Karan C. All these are, yes, they have said correct because IHE targets include 20 targets. IHE target contains 20 targets. And the irony is what? Irony is not a single target has been achieved. Clear? Now consider the following statements and select the correct code. The COP15 to the CBD was convened in 2 phases. Yes. One was convened at Kunming. Kunming is in China in 2021. And second was convened at Montreal. Montreal is in Canada. And that was in 2022. So 2 phases. And that was due to COVID that it was conducted in 2 phases. There were goals set to ensure that not only natural ecosystems are maintained, enhanced or restored sustainably with an overall increase in the area of natural ecosystem by 2050. So certainly natural ecosystem area would be enhancing by 2050, that's correct. Another goal is to ensure a 10% reduction in extinction rate of species. That's also correct. Clear? First of all, the natural ecosystem would be enhanced in 2050 and a 10% reduction in extinction rate of species. Clear? So we can see that all the 3 statements are correct in this. And remember these statements for your examination. Which one of the following statement is incorrect? And let's see the statement also and then we'll find out which is incorrect. The global biodiversity framework will replace the IHE targets. That's correct. There are 23 targets in the global biodiversity framework to be achieved by 2030, which includes 30 into 30 targets. Yes. 30 into 30 targets means bring 30% of geographical area by conservation by the year 2030. And this is, India is not a member of 30 into 30 targets. High Ambition Coalition is a group of 113 countries, aims at bringing 30% of the geographical area under conservation by 2030, also known as 30 into 30 targets. So what is incorrect in it? Tell me what is incorrect in it. Yes, they only conduct, yes. They only conduct meeting, making conventional rules, but nothing is happening. The syllabus is enhancing, definitely. Now, the incorrect answer is definitely all of you. Good, very good. All of you, they are saying C, and C is correct answer because India is a part of 30 into 30 targets. Clear? India is a part of 30 into 30 targets. Very good. Fine. So let's now start with another topic, and let's start with the topic global warming and climate change. Clear? Global warming and climate change. Now, first of all, the basics of global warming and climate change, and then India to pehle aayega, I think, yes, first, very good. Now, let's start global warming and climate change. Now, we know that the basic concept, we know that the greenhouse gases which are present in the atmosphere are responsible for moderating the temperature of Earth, because in the absence of greenhouse gases, the temperature of Earth would be minus 20 degree centigrade. We are saying that in the absence of greenhouse gases, the temperature of Earth would be minus 20 degree centigrade if greenhouse gases are not present. And how they are responsible for moderating? If suppose these are the greenhouse gases, for example, CO2 is greenhouse gas, methane is a greenhouse gas, water vapor is a greenhouse gas. So, if these gases are present in atmosphere, they happen to be transparent to incoming solar radiation of a shorter wavelength. So, they are transparent to incoming solar radiation of a shorter wavelength. So, transparent means they allow the incoming solar radiation of a shorter wavelength to penetrate into it. And what is the incoming solar radiation of a shorter wavelength? The incoming solar radiation of a shorter wavelength is from 0.2 to 4 micrometer. 0.2 to 4 micrometer. Clear? Incoming solar radiation of a shorter wavelength. And they absorb the infrared radiation generated from the surface. They absorb the infrared radiation generated from the surface. Clear? Responsible for absorbing the infrared radiation generated from the surface. Now, this infrared radiation which is generated from the surface is of a larger wavelength. So, larger wavelength is what? Larger wavelength is from 4 to 100 micrometer. That is called as larger wavelength. Clear? From 4 to 100 micrometer. And it is not that they are also only absorbing, but they also revert them back. So, when they are reverted back, clear? When they are reverted back, now this reverting back of infrared radiation is called as what? It is called as what? It is called as, either you can call it counter radiation forcing, or you can call it what? You can call it carbon flux. So, we can call it counter radiation forcing, or we can say that this is carbon flux. Clear? This is carbon flux, counter radiation forcing or carbon flux. And what happens? That this is a natural phenomena through which the temperature of Earth is getting moderated. Natural phenomena through which the temperature of Earth is getting moderated. But the problem is what? The problem is rising industrial emission. We will discuss albedo. Just wait, Cristiano, just wait, we will discuss albedo also. The problem is rising industrial emission. And due to rising industrial emission, what is happening? The level of greenhouse gases are enhancing. So, when the level of greenhouse gases enhance, more and more absorption of infrared radiation would be taking place. And if more and more absorption of infrared radiation is taking place, then certainly these long wavelength radiation absorbed by high clouds or low lying cloud. I will just explain, just wait for a few minutes. After I complete global warming, if there is any question, then ask. Just wait, because serious clouds are there. So, just let me explain all these things, and from preliminary point of view, I am explaining this. You will get the questions right also. Clear? Generally, what happens? High altitude clouds enhance global warming. Low altitude clouds reduce global warming. We will discuss that, we will come to it, because let us move in a sequential manner so that everything is completed, we revise, because that is a revision marathon. So, let us indulge in this marathon and let us complete. Clear? And now see, we will come to it. Don't worry about this. Now, this is called as, this is how the temperature of Earth is getting regulated, because if the greenhouse gases is not present in atmosphere, the temperature of Earth would be minus 20 degree centigrade. But the concern is what? The concern is rising industrial emission. And rising industrial emission is a concern. It means what? It means that yes, cirrus clouds. Cirrus clouds are high-ranging cloud, 15 to 45,000 feet they are, and they are consisting of large ice crystals. So they are responsible for absorbing more and more of infrared radiation and less of albedo phenomena. We'll come to it. But there are many things associated with that we have to know, because questions have been asked on that. So let's complete that. First of all, let's complete that, then we come to that. Now we can see that this is called as counter radiation forcing or carbon flux. So the temperature of Earth is getting regulated because of this. Now with rising industrial emission, the level of greenhouse gases are enhancing, and they are absorbing more and more of infrared radiation, which is leading to enhancement in temperature of Earth, which is termed as global warming. And since temperature is related to a number of geographical phenomena, that's why we say that climate change due to global warming is inevitable. Climate change due to global warming is bound to take place. Now, that's one thing, but this is a basic part of global warming, may not be asked in examination. Let's start from where the questions are coming in your examination. Suppose this is the sun, and we can see that this visible yellow part of the sun is referred to as what? It is called as photosphere. The temperature of the photosphere is 5,500 degrees centigrade to 6,000 degrees centigrade. That's the average temperature of photosphere. The sun is what? The sun is a gaseous mass. We are saying that the sun is a gaseous mass, and that's the temperature of sun, 5,500 degree centigrade to 6,000 degree centigrade. That's the average temperature of the sun. We can see that as far as temperature of the sun is concerned, on the photosphere of the sun, there are certain areas where temperature would be certainly low. Clear? We are saying that on the photosphere of the sun, there are certain areas where the temperature would be low. So these areas where the temperature happen to be low are referred to as what? They are referred to as sunspots. So the first thing about sunspot is temperature is low. But the second thing about sunspot is what? That these are temporary in nature. They are never permanent. Why? Because they would be getting converted into lit up areas after some time. Clear? They are getting converted into lit up areas after some time. And as far as sunspots are concerned, we can see also that they happen to be localized magnetic fields. Localized magnetic fields. So they are sunspots, they are localized magnetic fields. Now, that's about sunspot. It's also said that the area where sunspots are present in large numbers. See, the activity of sun is responsible for, the solar activities are responsible for formation of sunspots, and there is a sunspot cycle also. Sometimes what happens that the solar activity enhances. So enhancement of solar activity takes place every 11th year. Now this phenomena is called as what? This phenomena is called as solar flare. Clear? Solar flare. And sunspots would be what happening? Some sunspots would be getting converted into lit up areas, and some lit up areas would be getting converted into sunspots. But that happens, and as solar activities are responsible. The area where sunspots are present in large numbers on the sun's photosphere is called as what? It is referred to as benevolent monster. क्या कहते हैं उसे? Benevolent monster, where the sunspots are present. Interesting name. Where sunspots are present in large numbers. But when we talk about the atmosphere of the sun, we can see the atmosphere of the sun is called as what? It is referred to as chromosphere. That's the atmosphere of the sun. And the outermost part of the chromosphere is called as what? It is called as corona. Clear? So we can see atmosphere of the sun is called as chromosphere, and the outermost part is called as what? It is called as corona, very famous name today. And from the corona, flames erupt. Now can you tell me what is the name of these flames? What these flames are called as such. So from the corona, the flames erupt, and these flames are referred to as? No. Corona, from the corona, this is the outermost part of the sun's atmosphere, the flames erupt. Now, they are not called as solar flares, they are called as prominences. They are referred to as what? They are referred to as prominences. Look at Gochi along. They have mentioned that these are often 1000 kilometers in length, and they are called as what? They are called as prominences, not solar flares. Now what happens that from the sun's photosphere, from the sun, not only light is directed towards the earth, but from the sun also we can see charged particles would be directed towards the earth. We are saying that from the sun, charged particles would be directed towards the earth. So these charged particles which are directed towards the earth includes protons, includes electrons, includes alpha particles. So we are saying that these includes protons, these includes electrons, these includes alpha particles. Alpha particles are what? Doubly charged helium atom. Helium atom. These are protons, electrons and alpha particles. Now these are directed from sun towards the earth. Clear? These are directed from sun towards the earth. So when they are directed towards the sun, towards the earth, this coming of charged particles from sun towards the earth is called as what? It is called as solar wind. Solar wind. And in technical terms, it would be called as what? It would be called as CME. CME stands for what? It stands for coronal mass ejection. Coronal mass ejection, because it's coming from where? It's coming from corona. Clear? Then we can see that if you look at the magnetic field of the earth, the magnetic field of the earth has two imaginary ring-shaped belts. Now these two imaginary ring-shaped belts of the earth's magnetic field is referred to as what? It is called as Van Allen belt. That's called as what? It's called as Van Allen belt. So the charged particles which is coming from the sun towards the earth would be first of all getting accumulated in the Van Allen belt, that is proton, electron plus alpha particles. Alpha particles. So they are getting first of all accumulated in the Van Allen belt, and as the earth rotates, these charged particles would be pushed towards the poles. So when these charged particles are pushed towards the poles, they would be responsible for striking. CME is solar storm. They are responsible for striking different kinds of gases which are present in the atmosphere of the earth. So the different kinds of gases, there are two main gases which are present in the atmosphere of the earth. One is oxygen and second is nitrogen. So if suppose they are responsible for striking nitrogen, we can see that if they strike nitrogen, blue and purple color would be generated. And if they strike oxygen, green and red color would be generated. So when they are striking different kinds of gases present in the atmosphere of the earth, we can see that present in the atmosphere of the earth, then colorful streaks of radiation would be generated. Clear? They would be responsible for generating colorful streaks of radiation. So colorful streaks of radiation appear to be in the form of different frequencies. So, you can see when they are striking the different kinds of radiation, they generate different frequency levels. Now, these frequency levels would be visualized to us in the form of colorful streaks of radiation, which is called as what? Which is called as auroras. Clear? So, at the North Pole, it would be called as what? It would be called as aurora borealis. And at the South Pole it would be called as what? It is called as Aurora Australis. So, one at the North Pole Aurora Borealis, and at the South Pole it is called as Aurora Australis. And remember then, when nitrogen would be striked by these, blue and purple radiation would be developed. When oxygen is striked, green and red radiation would be developing. So, that is called as aurora, colorful streaks of radiation. Clear? Now, what happens as an observation, we have seen that every 11th year the solar activities enhances, and when solar activities enhances every 11th year, this process which takes place on the photosphere of the sun is referred to as what? It is called as solar flare. So, see what is solar flare? This process which takes place on the photosphere of the sun. No, solar wind is another thing. Solar wind is called as charged particles which is directed towards the earth. Solar flare is due to enhancement of solar activities on the photosphere of the sun. Clear? Now, this is called as solar flare. Now, solar flare would be responsible for what? It would be responsible for pushing more and more charged particles towards the earth. So, when more and more charged particles would be pushed towards the earth, when more and more of charged particles are pushed towards the earth, what will happen? The intensity of aurora would be magnifying. So, when the intensity of aurora magnifies, this phenomena is called as what? Intensity of magnifying of intensity of aurora. This phenomena is called as what? This phenomena is called as solar tsunami. So, solar tsunami would be witnessed where? Solar tsunami would be witnessed in North Pole and South Pole. And in UPSC question, they have tried to confuse you that enhancement in the intensity of auroras would be responsible for tsunami in the equatorial area. Certainly not. Clear? Certainly not. Because enhancement of auroras won't be taking place in the equatorial area because of this. And solar tsunami is responsible for what? The North Pole and near the South Pole. They are responsible for what? They are responsible for failure of electricity grid, because these are charged particles. They are also responsible for what? They are also responsible for communication network failure, because these are charged particles. And if suppose you are conducting research near the North Pole or the South Pole, your research would be also getting disrupted because these are charged particles. Clear? Your research is also getting disrupted because these are charged particles. Fine. So, that is called as solar tsunami, that is called as solar flare, that is called as solar wind, CME, prominences, etc. Clear? But I haven't covered up. I have just started my discussions. So, are you ready for today's revision class? Bachcho, are you ready for today's revision class? You will continue till midnight, 2:30, 3 o'clock or 4 o'clock, tell me, or 6 o'clock in the morning, and then we will go to sleep. So, what is your program? Can we do so? With all different kinds of tests, in between the test would be running also. Just now we have solved the test on CBD. After some times we will solve the test on COP27 also. And try to solve as many questions as we can. Fine. 6 a.m. Who is going to stay with me till 6 a.m.? जब तक आप हो, वेरी गुड, जब तक मैं हूँ. हाँ, बायोटेक्नोलॉजी भी खत्म करेंगे. बायोटेक्नोलॉजी अर्धरात्रि में शुरू करेंगे बच्चों, और उसे कंप्लीट करके ही छोड़ूंगा मैं. फाइन. एंड yes. ओके चलो आज रिवाइज करो पूरा. लेट्स रिवाइज इट वंस मोर. वट एवर यू हैव स्टडीड एंड वट एवर आई हैव फ्रॉम माई परस्पेक्टिव, लेट्स इंक्लूड दैट इन योर स्टडी. क्लियर? चलो आज करते हैं. Now this is one thing, but the second thing is what? That this is suppose the sun and this is the earth, and this is the amount of solar radiation which is directed from the sun towards the earth. Now if this amount of solar radiation which is directed from the sun towards the earth reaches the earth in toto means in exact manner, जिस तरह से निकल रहा है उसी तरह से पहुंचे. If it reaches the earth in toto, the earth won't be a hospitable place to live in. Clear? The earth won't be a hospitable place to live in. And that's why what happens, because the earth would be very hot. That's why what happens, that 1/3 of the solar radiation which is coming towards the earth would be reflected back. So the reflecting back of 1/3 of the solar radiation thank you so much Pankaj, thank you so much. अभी है बच्चा हुआ बच्चों, अभी वी हैव स्टार्टेड एंड देखो उसमें फिर वी हैव टू कंप्लीट ऑल द टर्म्स. For example, what is climate justice, what is carbon justice, what is red plus, what is your Panchamrit, what is climate ambition coalition, all these terms up till COP27 we have to complete. Some terms of COP27 we would be completing through test and some in the class itself. Clear? So let's connect all those things, integrate. But so जैसे तुम सुबह मॉर्निंग में जगोगे, you would be having the knowledge of a number of environmental facts by morning. Clear? इसलिए करना है बच्चों. Let's. So 1/3 of the solar radiation is reflected back. Now the reflecting back of 1/3 of solar radiation is referred to as what? It is referred to as albedo phenomena. Clear? We are saying that the reflecting back of 1/3 of solar radiation is referred to as what? It is referred to as albedo phenomena. Thank you so much. Thank you so much, Civils Simplified. Okay. The reflecting back is called as albedo phenomena. In albedo phenomena, we can see 60% contribution is made by what? 60% contribution is made by the ice cover. Ice cover means permafrost region. 30% contribution is made by clouds. So we can see the two main agencies which are responsible for conducting albedo phenomena is what? It is the ice cover and it is the clouds. Two main agencies which are responsible for conducting albedo phenomena is your ice cover and also the clouds. Clear? 60%. Now, see what you have to study here. We know that 30% is performed by clouds. Now, there is a term which is called as cryosphere. Cryosphere means, cryo means ice. So, cryosphere is that part of biosphere which is covered . Yes. Yes, white paints. Now see, we are talking about what? That 30% of albedo phenomena is performed by clouds. Now, the factors which are responsible for affecting albedo phenomena includes the nature of surface, whether it is smooth or whether it is coursed, which also includes the angle at which it strikes, the radiation strikes. It also includes the color of the surface. So these are factors which are responsible for influencing albedo phenomena. But when we talk about cryosphere is that part of the biosphere which is covered with ice. अब देखो एक क्वेश्चन मैं तुम्हें दे रहा हूं और उसके बाद ये डिस्कस करते हैं. I am saying that consider the following statements and select the correct code. The first statement is melting of polar ice would further aggravate global warming. Aggravate global warming. Clear? Second is melting of polar ice, melting of permafrost. Let's change the words. Melting of permafrost would result in absorption of methane and CO2. And third, melting of permafrost melting of permafrost would result in mercury contamination of the ocean. Mercury contamination of oceans. Let me put it like this. And I have given you the option 1, 2, 3. B is 1, 2. C is 1, 3. Clear? And 4 is what? Only 1. Tell me, what is the answer? And then we'll connect all these things with whatever we are going to study. Prominences का exact meaning क्या है बच्चों? Prominences exact meaning is the flames which erupt from the corona, which are 1000 kilometers sometimes in length. So some say it is C, some say it is B. Okay. All, some say it is all. No, it's not all. Let's study that. Let's study that and make it very clear that what is the correct answer. Not at all D. Clear. The answer is C. The answer is C. This statement is correct first and this statement is correct. So the answer is C. 2 is wrong. Definitely 2 is wrong. But let's study this, that what exactly is the meaning. Now when we are talking about cryosphere is that part of the biosphere which is covered with ice. It's that part of the biosphere which is covered with ice. So it means the polar ice would be a part of cryosphere. The mountain glacier would be a part of cryosphere. And cryosphere includes the permafrost region also. So permafrost region, we say that this region is covered with ice. And this is a region where even the summer solar radiation is unable to thaw, unable to melt the frozen soil. Or we can say permafrost region is a region where even the temperature of this area does not enhance beyond the freezing point for 2 consecutive years. 2 consecutive years. Now this is called as permafrost. The formation of permafrost would be taking place where? Formation of permafrost takes place at high altitude, that is polar region, and at high mountain glacier, and that high altitude, that is polar region. Very good. Now we are saying that we have studied in a stereotyped manner that when global warming takes place, polar ice melts, sea level rises, some of the small islands like Maldives can be inundated. Clear? Thank you so much, Samiksha. Thank you so much, Kamal. Fine. So we would be अच्छा मुझे एक्सप्लेन कर ले तो मुझे एक्सप्लेन कर दो बस सारी चीज समझ जाओगे. Now we are saying that melting of polar ice is responsible for what? It is responsible for rise in sea level. Clear? But melting of polar ice also means that the permafrost is getting reduced. And if permafrost is getting reduced, we can also say that if permafrost is getting reduced, it means that the albedo phenomena performed by permafrost is also getting reduced. And if albedo phenomena performed by permafrost is also getting reduced, this is enabling the solar radiation to reach the surface of the earth in greater abundance and would be contributing more and more into global warming. That's one connect. The second connect is what? The second connect is that as far as permafrost region is concerned, in permafrost region we have discussed that gas hydrates are present. So gas hydrates are present at extremely low temperature like permafrost region, or at low temperature and high pressure like oceanic floor. Clear? So formation of gas hydrates. So when permafrost region is melting, gas hydrates would be disassociating, and disassociation of gas hydrates would be responsible for emission of methane, and this methane would be emitted into the atmosphere, and this would be responsible for what? This would be responsible for enhancing global warming further, because it's a greenhouse gas. Remember the Holocene period which you have studied in history or geography. Holocene period is shale gas. बच्चों दूसरा चीज है, shale gas is the gas which is present in sedimentary rock, and that is sedimentary rock, and shale is a sedimentary rock, so we extract shale gas through method which is called as hydraulic fracking. But the second thing is what? The third thing is what? That during the Holocene period, during the Ice Age, large amount of CO2 was absorbed in the formation of cryosphere, that is in the formation of permafrost region. So when it melts, it would be emitted, it would be released, and CO2 would be released, and this would be further aggravating global warming. Clear? Further aggravating global warming. And you can see fourth is what? That sometimes you would have seen pictures of animals or vegetation being trapped in permafrost region, which is unveiled due to its melting. So when it is unveiled due to its melting, it would be undergoing decomposition. If aerobic decomposition takes place, then CO2 would be released. If anaerobic decomposition takes place, then methane would be released. Here, then methane would be released. So in all the four connects in above, we can see that global warming is itself responsible for enhancing its impact. So if global warming is itself responsible for enhancing its impact, this phenomena is called as what? If global warming is itself responsible for enhancing its impact, this phenomena is called as what? It is called as feedback effect. It's called as what? Feedback effect. Is referred to as feedback effect. Clear? Fine. And also we can see, now next, just wait, that the enhanced rate at which CO2 or methane would be released from the permafrost region, the enhanced rate at which CO2 and methane would be released from the permafrost region. Now this enhanced rate would be called as what? It would be called as carbon bombing or carbon bombs. So if a question is asked on carbon bombs, do not write that this is a matter of internal security of India, as the Al-Qaeda, Jaise Mohammed, etc. have responsible for developing it. But or Pakistan is responsible for developing it, but it is nothing connected to the internal security of India. It is taking place from permafrost region. Clear? Permafrost region. Now, carbon bombing. Yes, carbon bombing. Now, see, increase in water level would lead to greater absorption of CO2, but also we can see increase in water level would result in inundation of the coastal area. First of all, that's a major concern for us. And water level in CO2, if suppose we are talking about absorption of CO2, which is less absorbed when comparison to the inundation that it would be responsible for. Clear? I think that's clear. But see, one thing more, the last part of it. Now, when you talk about mercury contamination, we know that mercury contamination took place in 1952 in Japan and was responsible for contamination of the fishes. People ate those fishes, they fell sick, and Minamata disease was reported. In a stereotyped manner, we have learned this from our school days. Clear? Fine. Now, mercury. For long, we believed that mercury is present in ocean as a natural source. The natural source of mercury is nothing but oceans. That was the belief that we had earlier. But the perception has changed. Now, today we believe that the mercury which is present in the ocean is not present naturally, but it is the same mercury which was present in the atmosphere, which has been absorbed in the oceans. And how it is coming to the oceans? Because there is a mercury which is called as legacy mercury. Legacy mercury means the anthropogenic activities of the past, that is when industrialization started. So when industrialization started and there were anthropogenic activities earlier, now these anthropogenic activities, due to this, the mercury was present in the atmosphere. Whatever anthropogenic activities we conducted during that period, due to which mercury was present in the atmosphere. I'll explain again. मरकरी वॉज प्रेजेंट इन एटमॉस्फेयर. देखो, कार्बन बॉम्बिंग का मतलब है क्या? चार तरह से हमने बताया है कि कैसे CO2 मीथेन एमिट होता है परमाफ्रॉस्ट रीजन से. पहले कैसे बताया है? फर्स्ट इज दैट होलोसिन पीरियड में CO2 का अब्जॉर्प्शन हुआ था परमाफ्रॉस्ट रीजन में, क्रायोस्फीयर में, तो अगर वो मेल्ट करता है तो CO2 निकलेंगे. दूसरा मैंने बताया कि गैस हाइड्रेट्स का रीजन है, गैस हाइड्रेट मेल्टिंग के कारण टूटेंगे तो मीथेन निकलेगा. तीसरा मैंने बताया आपको कि यहाँ पर ऑर्गेनिक मैटर ट्रैप्ड है, जैसे डेड प्लांट्स, एनिमल्स, सेंचुरी से it is under the ice cover, so melting would be responsible for what? Exposing of this kind of organic matter. Clear? Exposing of this kind of organic matter, and this organic matter would be exposed clear. This organic matter would be exposed, and when organic matter would be exposed, it would be decomposed by what? It would be decomposed by if aerobic decomposition takes place, CO2 would be released. If anaerobic decomposition takes place, methane would be released. So we are saying that the enhanced rate, मान लो जिस दर से, जिस गति से मीथेन या CO2 परमाफ्रॉस्ट रीजन से निकलता है या क्रायोस्फीयर रीजन से निकलता है, उस गति को हम लोग कहते हैं कार्बन बॉम्बिंग, क्योंकि निकल क्या रहा है? दोनों कार्बन compounds. So that is called as carbon bombing. I hope that's clear. But as far as mercury contamination is concerned, we can see that mercury which is present in the ocean is the same mercury which was present in atmosphere. And this mercury which was present in atmosphere was called as what? It was called as legacy mercury. Legacy mercury is due to the anthropogenic activities of the past. तो जो एटमॉस्फेयर में मरकरी प्रेजेंट है उसको हम लोग कहते हैं लीगेसी मरकरी, और वो ड्यू टू द एंथ्रोपोजेनिक एक्टिविटीज ऑफ द पास्ट, इसके कारण प्रेजेंट है. बट व्हाट हैपेंड वाज दैट मरकरी फ्रॉम एटमॉस्फेयर वाज नॉट ओनली अब्सॉर्ब्ड इन द सॉइल, बट मरकरी फ्रॉम एटमॉस्फेयर was not only absorbed in the soil, but mercury from atmosphere was also absorbed in the permafrost region. So when it was absorbed in the soil, what happened was that the rivers eroded it and made it way to the ocean. So the mercury which is present in the ocean is nothing but legacy mercury. लेकिन देखो ये क्या हुआ कि न केवल वो सॉइल में अब्जॉर्ब हुआ था बल्कि परमाफ्रॉस्ट रीजन में भी अब्जॉर्ब हुआ. So when it has been absorbed in the permafrost region, we can see that when polar ice melts, mercury would be released, and this mercury which is released would be carried by the oceanic currents, not oceanic currents, perennial rivers, from the permafrost region to the ocean. Now this would be responsible for enhancing the mercury contamination of the ocean. Clear? इससे क्या होगा? मरकरी कंटैमिनेशन ओशन का बढ़ जाएगा. दिस वुड बी रिस्पॉन्सिबल फॉर इनहेंसिंग द मरकरी कंटैमिनेशन ऑफ द ओशन. एंड द कोस्टल एरिया ऑफ द ओशन is only 0.2% of the entire ocean, but this would be receiving more than 25%, 25 to 30% of mercury deposition. That's one fact. This coastal area of the ocean, you know, is an area of enhanced ecological productivity. This would be hampered. Coastal area degradation would take place due to mercury contamination. And it's not that there are also riverine contributors of mercury in the ocean. कई rivers हैं जो mercury के contribution. Yes, it would be having an effect on corals also. Now, there are riverine contributors of mercury in the ocean. There are three big riverine contributors of mercury in the ocean, which includes Amazon, 22%, which includes Ganga, 11%, which includes Yangtze, 4.9%. So, these are big contributors of mercury in the oceans. Clear? Big contributors of mercury in the oceans. Now, this is called as mercury, but mercury is also present in electronic waste. In the computer monitors, mercury is present. Mercury is not only present in the electronic waste, mercury is also present where? It is present in the waste of coal-fired thermal plant. And if we talk about the waste of coal-fired thermal plant, we can see that the mercury present in the waste of coal-fired thermal plant is many times more than that present in CFL. So, what needs to be done is to curtail the mercury content of waste in coal-fired thermal plants. We can use a gas, and that gas is bromine. So, bromine is damaging to ozone layer, but bromine can be used for reducing the mercury content of thermal plant waste. Now, how many questions are there? See, questions ही questions है इसमें. All these are nothing but questions. Fine, I hope that's clear. I hope that's clear. Now, next thing that you have to cover up is the significance of clouds in global warming. Significance of clouds in global warming. Yes, we are great culture also worships mercury siblings. That's great, fine. But this is about mercury contamination, and you can get questions on this easily. Fine. Now, let's understand the contribution of clouds in global warming. Now, we know that clouds are responsible for performing 30% of albedo phenomena. Very good. So, if they have performed 30% of albedo phenomena, it means more of cloud cover. More cloud cover, if it enhances, then global warming would be reduced. Clear? That's first conclusion that we can draw. But there is a type of cloud which is called as what? Which is called as cirrus cloud. Clear? And cirrus cloud are what? Cirrus clouds are high ranging cloud. मान लो कि ये high ranging clouds हैं, cirrus clouds. So, you can see cirrus clouds are generally present at a height of 14,000 to 15,000 feet. That's a high ranging clouds. In stratosphere, there is only one cloud, and that is what? Polar stratospheric clouds, which we have studied. But below that, the high ranging clouds are cirrus clouds. Now, cirrus clouds are responsible for enhancing the adverse impact. We say clouds in general reduce the adverse impact of global warming. But cirrus clouds are responsible for enhancing the adverse impact of global warming. But how? We can see that cirrus clouds have large ice crystals. बड़े-बड़े ice crystals इसमें, large. And they are responsible for absorbing the infrared radiation which is generated from the surface. They absorb it. They are also responsible for reverting it back. That is carbon flux, or we can say what is called as counter radiation forcing. So, cirrus clouds are responsible for absorbing the infrared radiation generated from the surface as they have large ice crystals, and they are also responsible for reverting them back. Clear? Reverting them back, which is called as what? Which is called as counter radiation forcing. Counter radiation forcing. Radiation bank. Clear? And they are responsible for performing less of albedo phenomena. This is less and this is more. This is more. So, absorption of infrared radiation is more, production of counter radiation forcing is more, absorption of albedo phenomena is less. So, you can see they are responsible for enhancing the adverse impact of global warming. On the other hand, if we talk about the low-lying clouds, low-lying clouds would be having small ice crystals, small ice crystals, छोटे-छोटे ice crystals, and small ice crystals, they behave differently. Why? Because small ice crystals would be responsible for reflecting more, that is, more of albedo phenomena would be performed. See, if I say that this is the ice cover, large ice cover that I have, my palm, this. Now, this is responsible for performing albedo phenomena. But if this breaks into small ice crystals like this, the surface area for performing albedo phenomena would be enhancing. Clear? So, in this case the surface area is more, in this case the surface area is less. So, you can see this would be performing more of albedo phenomena and it would be absorbing less of infrared radiation. It would be producing less of counter radiation forcing. So, you can see it is absorbing less of performing less of counter radiation forcing, less of absorption of infrared radiation. So, as far as this is concerned, low-lying clouds are concerned, low-lying clouds are responsible for enhancing the adverse impact of global warming. But clouds in general, that is, clouds in general, clouds that is called as cirrus clouds would be responsible for enhancing the adverse impact of global warming, which are high ranging clouds. Is that clear? Yes, broken mirror reflect more light. Now, this is the same thing, but now one thing is that in the year 2010 we can see that the former ISRO chairman Mr. U.R. Rao, he was responsible for conducting a research and he came to the conclusion. The conclusion was what? The conclusion was see, ice crystals reflect more of insolation, that's correct. But if this is an ice crystal, this stylus, this is a big ice crystal, this much is the surface area. But if you break them into small pieces, the surface area would be enhancing. So, small ice the low-lying clouds have smaller ice crystals, surface area for albedo is more. Cirrus clouds have large ice crystals, the surface area is less. What is in that? Clear? Fine. Now, in the year 2010, we can see the former ISRO chairman, Mr. Dr. U.R. Rao, he was responsible for publishing a study and he came to the conclusion that in the last 150 years of time, the solar activities have reduced. And since the solar activities have reduced, the amount of solar radiation, the intensity of solar radiation is less. The intensity of solar radiation is less. So, if the intensity of solar radiation is less, it is intensity which is responsible for evaporation of water. It is intensity which is responsible for formation of clouds. So, if we are saying that the intensity is less, it means that the cloud cover over the earth have reduced. So, the observation made by Dr. U.R. Rao was that in the last 150 years of time, the cloud cover over the earth have reduced and this has reduced what? This has reduced the intensity of solar radiation, because of which we can see that the solar activity, the formation of cloud is less and the cloud cover over the earth has reduced. Now, this reduces the albedo phenomena and because of which what happens is that the incoming solar radiation would be striking the surface of the earth in greater abundance and this would be responsible for aggravating the influence of global warming. Clear? Aggravating the influence of global warming. But also we can see that an agreement was signed in 2017 And this agreement was signed between three countries. One is India, second is China, and third is US. And these three countries were signing an agreement for the purpose of what? For the purpose of pumping sulfate particles into atmosphere. So if you pump sulfate particles into atmosphere, what will happen? More and more of cloud cover would be seen. Clear? If you are responsible for pumping sulfate particles in atmosphere, more and more of cloud cover would be seen. And not only this would be seen, but we can see that if more and more cloud cover would be seen, then it would be responsible for reducing the adverse impact of global warming. So the three nations signed an agreement for pumping sulfide particles in atmosphere so that the more and more of cloud cover would be seen, and this cloud cover would be reducing the adverse impact of global warming. Clear? Reducing the adverse impact of global warming. Also, the agreement said that they would be developing technology for the purpose of thinning of cirrus clouds. Clear? They would be developing a technology, and this technology would be used for the purpose of thinning of cirrus clouds. So this agreement was mainly responsible for reducing the adverse impact of global warming. Clear? But there's also a type of cirrus cloud, and this cirrus cloud type is called as what? It is called as contrail cirrus. This type of cirrus cloud is called as what? It is called as contrail cirrus. Contrail cirrus means that this cirrus cloud is developed how? When it is developed from the exhaust of aeroplanes. Suppose we are saying contrail cirrus. Contrail cirrus cloud is developed from the exhaust of aeroplanes. Exhaust of aeroplanes. So the exhaust of aeroplanes consists of tiny particles. These tiny particles act as a seed nuclei, and these seed nuclei is responsible for what? Cloud seeding. And the type of cirrus cloud which is developed due to this is called as what? It is referred to as contrail cirrus. So this also aggravates the influence of global warming in the same manner that cirrus clouds are responsible for doing. Clear? Fine. I think that yes, mirror effect, good. Idealized crystals would be reflecting more. Yes, yes, got it, sir. Become big after broken. Yes, cloud seeding. And that's about significance of clouds in global warming. But there are many topics which needs to be covered up, small topics, and let's condense it to cover it because it cannot be covered in that much time. But whatever, let's have a session for that, and let's try to cover up as much topics as we can. Clear?